All right, I guess we're live here. Thank you guys so much for joining us on this seminar about again off flavors, and this time we're gonna dig in a little bit deep into the data, um, and it's gonna be fun. Hopefully we will demonstrate how important it is for you at your brewery and your QA and QC lab to be continuously analyzing your data and doing constant sensory analysis. So first and foremost, I am Amart Freire. I'm a product manager and I lead all sensory panelists at Siebel Institute. And joining me here is Katie Strain from MSU Denver. Siebel and MSU, we do have a partnership, and we collaborate on our analytical services and a bunch of other things. And here I'm bringing Katie Strain. She's gonna take you on this introduction about MSU. I want her to share a little bit about MSU, what it is that you guys are capable of doing, and then we're gonna tackle the compounding question, and then we're gonna look at some data, and hopefully have a lot of fun. All right, up to you, Katie. Tell us about yourself.
Okay. Hi, everybody. I'm Katie Strain, and I'm a lecturer in their Brewery Operations Program at MSU Denver, and I also am a lab manager for the QA/QC Beverage Analytics Lab at MSU Denver, powered by the Siebel Institute. So, we work with Siebel. We do a lot of their lab analyses, and today we're going to be diving into the test that they do a lot, which is the distillation and quantitation.
Hello, Katie. I think we're having some problems here with your mic.
Oh, okay.
Oh, there you go.
There it is.
You can hear me?
Yeah.
Oh, hi.
Better.
It was slow.
Yeah, I think you're gonna have to hear all of that again.
Okay, it's good. The first time wasn't good. No, just kidding. I'm Katie. I am the lab manager for the QA/QC Beverage Analytics Lab at MSU Denver, powered by the Siebel Institute. And I also am a lecturer for the Brewery Operations Program here at MSU Denver. And so, we partner with Siebel for a lot of the lab testing. And today we're going to do kind of a deep dive into two of the tests that I do quite frequently, which is quantitation of VDK, so 2,3-butane-dione and pentane-dione. And then we're also going to be comparing that to aroma analysis using GC-FID detection of the headspace. So we can kind of compare, see what the quantitation of other flavor and aroma compounds are compared to the diacetyl and how that affects the perception of flavor. So we do that. We do a lot of other testing. So alcohol, nutrition testing are probably my biggest ones. And we have a very capable microbiologist as well. So that's kind of a sum. I guess I'm broadcasting from our sensory lab. This is a really cool space that was designed. And as you can see, there's a lot of natural light because we're on the southwest facing corner of the building, which in Colorado, if you can take advantage of the natural sunlight, there's a lot of it. So that's great. The air is circulated in here 100% every 10 to 15 minutes. It's got its own HVAC system. We've got specially designed glassware that was actually developed here with Rito Spigelau. And, we've got light panels underneath. I don't know if you can see it.
I'm actually a little bit interested about some of the custom designs of your glasses or your glassware.
Yeah. So we've got, this is like the highball glass. So we use this one for IPAs a lot. So of course it's got the tapered on the inside. So that helps trap aroma compounds and stuff. And then also you can hold on to the bottom of it to help warm it up and release a few extra aromas. So like I said, this is our highball glass that we use a lot for IPAs. Got two Pilsner glasses. So this is our tall Pilsner. And then we've also got the stemmed Pilsner. And this is kind of like your tulip shape, but we use this most of the time for doing sensory analysis. This is kind of like our most common glass shape that we use. We've got, a Hefeweizen or Weiss beer glass. Yeah, lots of different stuff. So that was kind of cool because I didn't realize that those were actually developed here in this room until today. So that's pretty cool. But yeah, we love this space, and we hope to use it more. Starting in March, we'll have some in-person classes again and get students back in this room because it's been a while. But
That's amazing. Yeah.
yeah.
So a lot of the compounds that we're going to be looking at today in the analysis are one of the most common compounds that it got picked up about through this data analysis that Katie run. Those are one of the most popular, one of the most standout compounds. But I want to today we're gonna be comparing. We're going to be comparing the lab data versus my perceived. Kate and I were going to be doing a tasting of the beers that we ran the analysis from. And I'm going to spike here. I'm going to use the non-spiked beers as a control. Today we're going to have a standard American lager, a stout, or a dark ale, and an IPA, and we're gonna see how they match up each other. How perceivable? How perceivable this compound is? And the compound in question is diacetyl, which to me it's one of the compounds that gets thrown out a lot as far as people talk about it a lot, and it's a very it's always on the table, and it's always, oh, we hear diacetyl, this and that. So and I'm gonna compare it versus the spiked. I have the spikes here ready to go, and then we're gonna take a look at the hard data. Let's tackle a little bit about that. Let's talk a little bit about diacetyl. Let's talk about its production, how to avoid, and I'll say a few things on the subject. I spent a lot of time in breweries. I spent a lot of time, a lot of my career having hands-on in a production, and I got a chance to brew with different strains and see how it behaves differently, depending on the beer that you're brewing, depending on the raw ingredients. So diacetyl, it's produced and reabsorbed by the yeast. So the strain alone is going to dictate how much of it is produced. Now, on top of that, flocculation, there's a huge correlation between flocculation and leftover diacetyl production. So if you have those yeast cells in flocculation, they're going to help reabsorb a lot of the diacetyl, and then they're going to flocculate, and then you're going to end up with a beer more, I want to say, more stripped of diacetyl. If you have a strain of yeast that flocculates too fast, is highly flocculent, you're going to end up with a lot of those. You're going to end up with more. The tendency is to leave you with more diacetyl left over in the beer. Now, I want to highlight here one of the most flocculent strains there are the British strains, and one of the big reasons it was the selective pressure due to top cropping. Fermentation would kick off. They will flocculate. They will go to the top. The brewers would top crop the most flocculent yeast and then repropagate. So with that, the traditional British strains, they end up being very, very, very flocculent due to selective pressure, to taking only the most flocculent strains and repitching. Also, water chemistry will play a part on how much of the yeast will flocculate. So that's yeast alone. There's also certain bacteria like Pediococcus. It produces a lot of diacetyl, amongst others. What about you, Katie? What more can you add on the production of diacetyl from your experience?
I would say you got the production down pretty good. I would say one interesting thing is that you can continue to get VDK in your package. If you've got oxygen left in there, then you'll get a little bit more oxidation of the acetolactic acid. And so if you taste a beer at packaging and it tastes good, there's a chance down the road that you might be able to pick up a little bit of diacetyl. So it's good to do, kind of shelf life stability testing, or just, do sensory every once in a while, take a bottle out and make sure you're not picking anything up.
Yep, I have to agree with that. I think for every batch, every brewery should have under the QA QC protocols stored a few samples from what's out there, so you see how it behaves in the house, so if something happens, how to backtrack. If you found contamination, if you found whatever it is. Another thing that I think we didn't touch on yet, it was a draft. Draft beer, especially on those bars that have multiples, if not dozens and dozens of different beers, to make sure that those lines are cleaned out. Make sure that they service those lines. The standard, which is in most states of the United States, I think from what I know, all of them are regulation dictates that those tap lines have to be cleaned within 2 weeks. Every 2 weeks, those lines have to be cleaned. What happens a lot, mechanically speaking, is that when you have a line which is contaminated with some sort of bacteria, let's just say Pediococcus, if you have beer constantly flowing through that line, it will be harder for you to detect any flaws in that beer. But at the moment that the beer stays in the line, let's say overnight, or let's say if that beer is not flowing, you stop pouring from that line, you pour it again, that's when you pick up the diacetyl produced by those bacteria within the line. So it's very, very, very important that those lines are cleaned. If the beer is being poured from a brewery, I believe, from my experiences, breweries are much more concerned in the cleaning. They have brewers and assistant brewers and the whole staff dedicated to those beers. So it's of their interest to be cleaning those beers all the time. But bars may be different. I don't maybe. Hopefully they will understand the value of cleaning those lines, but that may not be the case. But it's very, very, very important. How are the beers out there in Colorado, Katie?
Oh, they're pretty. Okay, there we go. They're pretty good. I do a lot of routine analysis for the Tivoli Brewing Company. They're here on our campus, so they do VDK testing pretty much consistently, and they won't release a beer until it's below their threshold. So they're one of those that they've kind of figured out with their different beers, kind of what the sensory threshold is. So kind of going along with what we're going to be doing today, they've decided, okay, even if it's 500 ppb in this beer, can't really taste it, it's okay. So yeah, it's but I would say as a whole pretty good. Some of the sporting arenas, I think we've got some draft line issues, but yeah, I would say when you go to a craft brewery in Colorado, most of them got the tap lines clean. And
if you talk about, you have issues with, let's say, sport arenas, well, it kind of makes sense because they don't have, they're not open 7 days out of the week. They have a game or two once or twice a week, so it's kind of normal, and it may be natural to think, I'm not gonna clean out this beer that often because it's not getting utilized that often. But if you have a contamination, you're there and it sits for a week, you don't clean it, and I think it's more likely for you to have those issues. So it kind of makes sense. Now that you touched something that not everybody may be aware, you said 500 ppb. Well, just 500 parts per billion, which is it's give or take three times the threshold. So diacetyl, based on our findings, based on the average human detection of diacetyl, that will be about 200 or 200 parts per billion. And usually when we do sensory analysis to educate and show people what does diacetyl taste like in beers, we multiply that by 3. So it's a common thing, it's a very standard thing to say, when we do sensory panel, 3 times the threshold, 3 times the threshold. So that's to really come out. A lot of people, I've encountered a lot of my students that couldn't pick up at 600 parts per billion, and sometimes 800 parts per billion. So maybe that they don't know. And my advice to some people that cannot pick up or cannot understand is to times 6. Once you figure it out what it tastes like, and then you work your way backwards. To me, a flavor compound, or understanding a flavor compound, be able to detect and perceive a flavor compound, it's more due to memory. It's more due to, it's kind of like adding a word to your vocabulary. You know, once you know what it is, once you hear a word and you know the meaning of it, it's everywhere. You know, so I think that works very similar. It's a sense of yours. It's how it is subjective. It is tied to your memory. It is tied to your perception, but it's also objective. Like the data that we're going to see here, it's objective because those compounds are in the beer. Whether you can detect it or not, they are in the beer. So there is the subjective of the subject, but the objective, it is also very objective because we rely on data to measure those compounds as well. So so yeah, so that's I just wanted to cover the number that Katie just threw there. Correct?
Sounds good. Sounds good.
Good.
Sorry, my microphone.
No, that's completely fine. So again, we ran the test on those 3 selected beers. Let's go ahead. I'm going to share here my screen. Hopefully everybody will have a chance to look at it. We're going to start by the American Lager, and as we're doing this, I'm going to go ahead and crack mine open, and I'm gonna start getting used to those to the beers as a control. I'm going to use those as control as we're going through them. As we're looking at the data, as we're kind of trying to understand what it is that we're seeing. I'm gonna get myself comfortable with those beers. Okay. Can everybody see my screen?
Looks good on my end.
Great.
Okay, so so I did GC analysis. So what this is actually I take 10 milliliters of cold carbonated beer and I weigh that into a headspace vial. And the reason I do it cold and carbonated is because you want to keep as many of those highly volatile aroma compounds in the beer as possible. So the best way to do that is to keep it cold and to not degas it, because if you degas, you're going to release some of those compounds. So and that's why if you weigh it and you know the density of the beer, then you can kind of back calculate how much volume you would actually add to that headspace vial. But headspace analysis is great to do because it's great for highly volatile aroma compounds, and it's really clean because you're just sampling the air above your sample. And so what we do is,
can we name some of those highly volatiles?
Yeah, so acetaldehyde, ethyl acetate, isoamyl alcohol, that banana flavor that people are really familiar with. Diacetyl is another one. Unfortunately, with my method, diacetyl comes out right when the ethanol peak comes out. So that's why I have to quantitate that using a different method for now. I'm still working on the method to get those two separated, but it's kind of hard. These all have really low boiling points, and they're all mostly relatively small compounds, so they like to elute off the column pretty quickly. So especially diacetyl, it's pretty small in it. Mm-hmm. So anyway, that's kind of a chemistry problem. You guys don't have to worry about it.
Okay, so that's the American Lager. What would be? I'm just trying to look for a comparison here. Between the American Lager and the American IPA here, for example.
Oh yeah. So and you know.
Your mic is off again.
Standard. But and then that became between propanol and isoamyl acetate. That's isobutanol, and I just
Katie, your mic is off again.
Maybe it should be on.
No. There you go.
Okay.
You're good.
I think I just keep coming in and out. But yeah, so the one unlabeled peak in between N-propanol and isoamyl acetate, that is isobutanol. And I'm not gonna lie to you guys, I just forgot to quantitate it, so it didn't show up on the chromatogram when
That's not a problem.
But yeah, so it's kind of hard to tell. That's why you use an internal standard, because especially when you're dealing with very small injection volumes of air, there's a little bit of variability there. So it's hard when you're just looking at the chromatogram to really compare one beer to another. The giant peak next to ethyl acetate, I should let you guys know, that's just ethanol. So I don't quantify that because that's a big monster peak. But as you can see, Headspace produces a pretty clean chromatogram and, pretty good separation of all these compounds. So
I'm seeing there another increase on maybe this is standard there, but ethyl acetate to me, I tend to pick up those more with IPAs, or usually higher octane beers in general. I tend to pick up, especially when they age a little bit. I tend to pick up more and more ethyl acetate.
Yeah. If we go to the next, or go to the bar graph, that's got more of the actual numbers on it. So, this one, here we go. So this is the quantitative data, and this is good. It tells you how much is in your beer. As you can see, there's no acetone, there was no methanol, so I didn't even quantify that one either. But you can see like the American Light Lager has the highest concentration of acetaldehyde. That's kind of that, apple-y or pumpkin, or however you think of that one.
Green apple, cut grass to me. There's a lot of that cut grass, especially with the American lager, with the standard American lager. You get to me, I really, it's funny because I tend to relate more with the crunch of a green apple than the smell and taste of it. For some reason, especially when it's paired with the grainy standard American lager, I think tends to be a little bit grainy as well. So
and then so this graph is good. It tells you what the quantitation is, but as far as information regarding sensory goes, this doesn't tell you very much, because you would look at this graph and think, wow, this thing's loaded with isoamyl alcohol. I should be detecting a lot of banana flavors. But if you go to the next graph, you can see isoamyl alcohol. This has been, going back.
There you go.
This has been normalized to what the sensory threshold is. And I think this means more, probably means more to brewers. So
your mic is off again. I don't know what's going on.
No. Should be on.
There we go.
Okay. Sorry, guys.
It's okay.
You can see in this graph, the isoamyl alcohol is a lot lower. So on this, I normalized everything to sensory. So anything with a value above 1.0 means that chemical is present at a detection level above what the average sensory threshold is. If it's below 1, then that means it's below sensory threshold. So this is where acetaldehyde and diacetyl become a little bit more prominent. On the other graph, they look a little lower. Ethyl octanoate, that's kind of that nondescript, like fruitiness, maybe a little bit of floral and perfumey. So that, that one's the highest one as far as like what you should be able to detect with sensory. So it's interesting to see, once you do the sensory, if this really carries over. But I think this graph is probably more relevant to, if you're trying to figure out how things are going, like if you're going to be able to smell and taste things.
Thank you so much for putting this one together here, Katie. This one shows this is the start of the seminar, because it just shows how it's the baseline for what we're about to do, right? I'm just here just for the sake of my own enjoyment here. Now, even though it shows the data, I'm here having those beer, and now I'm having the beers that we're drinking right now. And I honestly cannot detect So the way that I'm laying down too, the way that I always go by least flavorful to more flavorful, especially when we're doing different styles. So we start with the lager. Um, I move on to the dark beer, the sweet stout, and then the IPA. It's the more flavorful, all three of them. Cool, absolutely awesome. So right now, and then this is the one that we're gonna tackle here. Can we go over this one?
Yeah. All right. Can you guys hear me?
Yeah, perfect.
Okay, cool. So this one, so this is the blue part of the graph. That is the diacetyl content in each of these three beers. And this one I did a distillation followed by a spectrophotometer analysis since I couldn't get this with the GC. And then spiked, this is as if it had been spiked to that 3 times the threshold. So say it's at 600 ppb or 0.6 ppm diacetyl. So I thought this was really interesting because, in the American lager, you're going to detect diacetyl much more than you are in the other beer styles. So it's like a 7 times increase. And that's just because that style doesn't have as many of the other flavor and aroma compounds to kind of mask it. You see in the sweet stout, that actually had pretty much the same level of diacetyl as the American IPA, but because it's a sweet stout, you can perceive that more in that style according to the data. So, I mean, whether or not it works that way with the sensory will be interesting to see. But hopefully that kind of makes sense. So,
Okay. I'm gonna go here again. I'm gonna go back to the it is Budweiser. So this is the standard that we're using here for our sensory today. So we take a look at the color of the beer. We took a look at foam formation. This one then does not have a hat on it. We'll look at clarity as well. And aroma. To me, it's fresh. No signs of no diacetyl that I can perceive out of here. On the non-spiked. Yep. So diacetyl to me, I mean, it kind of is a given. If you have something that it's less flavorful, if you add something to it, it's harder to pick up. But it's just interesting to show with the data. It is fairly subdued on the aroma, or present, but on the rectal nasal, after you swallow, what comes back is on your face. Now, would I say it's 7 times increase based on the number that I'm seeing right now? I don't think so. I wouldn't judge. It's very hard to make math and in your head when it's something that you can't perceive, right? How can I quantify that in my head? How can I quantify what I just experienced? When you try to translate that into numbers, I wouldn't say per se, oh yeah, this is definitely 7 times stronger diacetyl. I don't know. So moving on to the sweet stout. Again, to me, no signs of diacetyl. Well, yep, very clean. And again, this is 3 times the threshold. So this is I just added about 600 parts per billion of diacetyl in each of those samples. I cannot detect any difference. It's fairly, yeah. I would have a hard time in a panel trying to look for diacetyl at 3 times the threshold on the stout. Other than they're from 2 different cans within the same pack, that's the only difference that there are to them. They're from 2 different cans, but they taste like the same beer. And I'll move on to the IPA. From all 3 of them, this one has the most head too. So head and temperature, head will keep some of the some of those flavor compounds down. When the bubble pops, that's when you pick up a lot of the flavor profile or the aromatic compounds, I should say. Yeah, but I do like the color beer, a little bit of turbidity. All of them very fresh, which makes it easier. Okay, now for the IPA. Interesting. It is fairly detectable. I can detect more, especially compared with the stout. Not so much on the retronasal, but definitely aroma. So looking at the, I would say perceived, again at 3 times the threshold, and on the IPA perceived a diacetyl is more than the stout, and about the same, if not a little bit less, but about the same as the American lager. That's my perceived analysis here, just by having those side by side between spiked and unspiked. Interesting, because I was not expecting, due to the IPA being hoppy, I would expect the hop characters to mask a lot of the diacetyl, but that wasn't the case. I actually perceived. It was substantially perceived, and especially if you compare side by side with spiked and unspiked. It's very interesting. I'm actually a little bit. It was not what I was expecting. I thought that the IPA was going to be the least detectable, but it turns out it was the stout. Maybe due to some of their sweet characters, maybe due to lactose, or maybe due to how it's made. I don't know, but it really surprised me. Did you have a chance to try them, to do this side by side, Katie? This control like sensory compound, sensory analysis?
Yeah, I have the beers, but I don't have the
Mm-hmm.
spikes. So you're better than me. I don't get a lot of diacetyl in any of them, but like I said, you're the sensory guy. So I think you're better at
Well,
it than I
yeah,
am.
I've done so many of them, especially with synthetic or synthetic compounds, or isolated
Yeah.
compounds, I should say. But it was very, very, very interesting. I really liked it a lot. Thank you so much, Katie, for doing this. Let's see if we got any questions. Let's open up for questions. Besides the beers, that already has been replied. It would be very interesting to see standard sensory thresholds in quotation marks for diacetyl in various common styles and compare those to the current standard sensory thresholds based on a light lager. Yeah, so that's pretty much what we're trying to establish, Josh. Uh, I think that the current threshold, what we just showed here right now, especially with certain on the case of the stout, the current threshold or the current three times the threshold standard to start detecting on a light lager is not the same for different beers. When I put this idea into paper, I thought about the outcome, but definitely this is what it proves, that it shows that we have to rethink the threshold if you're trying to detect off flavors or off flavors to your brewery. Uh, uh, Depending on the beer that you're brewing, depending on the beer you want to detect for, uh, your standard method has to adapt towards that beer. So we have to identify how much is starts to become perceivable, or what is three times the threshold depending on the beer. So that just becomes a little bit more complex, uh, uh, if you think about it. Can you speak to detecting diacetyl levels in tropical fruity beers such as New England IPAs, easier or more difficult? So, and I'll throw in my 2 cents on it, and Katie can talk about it as well. Um, so detecting diacetyl levels. So and here's the thing. We picked Two Hearted, which is it was it is a fairly standard IPA. It's not tropical. It does not have those Citra, Mosaic, which they tend to be very overwhelming. In my experience in drinking New England IPAs or hazy IPAs, uh, that they tend to be a lot. I picked up a lot of more captains in the past too. So I would assume that would be very, very hard to pick up diacetyl onto those, and that was my assumption. But then again, my assumption today was that the two-hearted IPA would be the least detectable, and that wasn't the case because it was pretty evident that there was diacetyl on the IPA at three times the threshold, the same, and it was about as detectable as the lager was. What do you think, Katie? Do you think that they would be more detectable? I don't know how much analysis you ran in New England IPAs, and what was your findings? Do you have any experience in those?
I actually have not done an aroma analysis on a New England IPA off the top of my head that I can think of.
Hmm.
The thing is, those when you're talking about hoppier beers, there's a lot of flavor compounds that aren't going to show up on the GC analysis that I did because they have higher boiling points. So it would kind of be a different GC method, and you would see all different compounds. So you would see more of the terpenes and myrcene and some of those kind of flavor and aroma compounds that are come from the hop essential oil, basically. So that'd be interesting to do. I would expect that, the more other stuff you can smell, the less diacetyl you can smell. But
Yeah,
yeah, who knows? I guess
right.
that's why it's important to do both, right?
It's very important to do both. So here we have Michael asking, any mouthfeel detection with the diacetyl spikes at all? In my experience, yes. It tends to be so. It could be a physical reaction. I actually don't have enough data on this. I'm going to talk about my perception using the three times threshold in a logger, because that's by far the majority of the sensory panels that I did was in standard American lagers. So to me, the mouthfeel is more viscous, that could be a combination in perception, not the actual physical reaction that it's having. It's more viscous. Let's think of a German wheat beer or German Hefeweizen when it's full, it's bodied. Uh, it's not filtered, so you think about it as being viscous, and you kind of it is a mouthful. It's also highly carbonated. It's about 3.3 to 3.2 volumes of CO2, whereas your standard American lager will be at 2.6 volumes. So it's more carbonated. So that plays in the combination of being unfiltered, having a lot of particles in suspension, and when it fills up your mouth, you really, it's a physical reaction. It is more viscous. In the case of the acetyl, I could say that it's similar, but maybe because we think about butter, or we think about butterscotch, or we imagine having butterscotch in our mouth when we clearly perceive diacetyl. So that's my mouthfeel perception, and I can testify for that. So but as far as data or any physical changes, I can't say that I can tell you that 100%. What are some practices that we can do to help articulate on our compound detection? Yeah, I think of, and I gave before I gave the comparison, and I used the analogy of adding new compounds as a vocabulary. Well, first and foremost, you have to kind of let go your personal preferences. Let's say me, I hate beets. Absolutely hate beets. Is there one thing that you hate, Katie, as far as food wise, or a thing that you refrain from ever touching again?
I
You,
love beets, so I'll take
I don't
yours.
understand people that like
um,
beets. It tastes like dirt. It tastes like soil. It
uh,
tastes like earth.
so good. You're so good. Um, I can't think of anything that I am totally averse to, but I do know just from testing red wines a lot and their aberration for Brettanomyces.
Okay.
That's one that I'm very sensitive to.
So
Like I
the
can,
barnyard mixed up with
yeah,
the barnyard mixed
yeah,
up with medicinal, sometimes some of those barrel
yeah,
aged
all
sours,
made,
right?
mousy, all that good stuff. Yeah.
So what I can say to help particularly your compound detection will be to let go of personal preferences, to really try to dissect what it is that you're tasting, to take notes, write it down, and to really try to dissect in your mind what it is that you're perceiving, what it is that it is that you're feeling, what it is that you're looking for, if you know what you're looking for. So because sometimes when you don't know what certain things taste like, kind of not knowing what's the meaning of a word, that word is just gonna go right through your head. You're not gonna detect because you don't know what you're looking for. You don't know the meaning of this. If you know what it tastes, the perfect combination is knowing what it tastes like, remembering what it tastes like, knowing its chemical structure, and I'll throw a plus, know where it comes from, right? So that will be the perfect combination to really become a good sensory analyst, right? And they talk about the super taster a lot. There are people that they are more susceptible to flavor compounds, right? There are differences on how we are built. We're all built a little bit differently. That is true to a certain extent. And there are the super tasters out there that it can taste something like they're good, but there is also practice. Anybody can be a sensory analyst. As far as I'm concerned, unless there are some people that have some inabilities and deficiencies, but the majority of people, I believe that through training, they can achieve becoming a good sensory analyst. And I'll give you what is the difference between having a German Shepherd as your pet in your home and a German Shepherd um, in the airport sniffing out for drugs. One is trained, the other one is not, and they're both built fairly the same. They're both same breed. We're all human, so training is a very huge part of becoming a sensory analyst. So don't be afraid, don't be shy of trying your things that you didn't like before. Oh, and you can learn how to like it. Unfortunately, I haven't learned yet how to like beets. I still I still don't like them, but I try them every now and then. I do try them every now and then. Why are you using 200 parts per billion as a threshold? That's a standard. That's when the human will start detecting the compound based on an average. Um, I can see if I can find links to the source of that data, but that's usually that has shown that that's when we start detecting that compound in average. But then again, people are built the same. I had some students of mine that couldn't detect uh, anything lower than 6 times. So at 1200 parts per billion, so and it's usually because people don't know how to taste, don't know what they're looking for. And I already covered the mouthfeel detection diacetyl. That's to me it's to me it definitely has a mouthfeel difference. Katie?
Hey.
No, just looking for your input and
Oh,
if there's anything to add to my comments here.
oh no, I mean, yeah, I usually like for I think for the sensory normalization, I either used 150 or 200 ppb for diacetyl. I
Yeah,
can't remember.
150 to 200. Yeah,
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 some,
that's about
some of
right.
those. Yeah.
So yeah, so anybody here on this call that there's looking or in the seminar there's looking to get down I want to say down and dirty with the analysis and the analytical read on the beers that you guys are producing. Don't be shy to if there's anything that you see in a list of analysis that we have available. Don't be shy to ask if we can, uh, excuse me, if we can run what it is that you guys are looking for. So because we can adapt, and there's a lot of resources here between Siebel and MSU, and I'm sure that we can make something work. But it's that I really enjoyed this, and I can't wait until I can be out there at your sensory lab, Katie, and run some sensory training with you guys.
Oh, that would be great. I'd
Right.
love to have you guys out.
Absolutely. All right, guys, I think that's all for the questions. I want to thank everybody's time. Feel free to reach out via social media. This video will be uploaded on YouTube on Siebel's channel. So go check it out for references. Go take a look at our data. If there's any questions, feel free to leave a comment. And yeah, thank you so much, Katie, for your time and putting this together.
Of course.
We've
Thank you.
been planning for about a month or so. Yeah.
Yeah, it was interesting. I like to do this with more beer styles too.
Let's let's see how Diacetyl stack up on a couple of sours then.
Yeah, let's do that. I think that'd be cool. We could throw a New England IPA in there.
Maybe the sours and barrel aged beers. How about that? That will
Ooh,
be.
yeah.
We're probably gonna have to 6 times, 8 times at least the
Yeah.
threshold. Awesome, guys. I really appreciate this. This has been very eye-opening, and stay tuned to more seminars that we'll put together.
Yeah. Thanks, everybody.
Thank you.